Hello and welcome. In this video lecture, we learn how to convert from decimal to binary numbers. The method itoa converts an integer value to a string. If you dive into the source code of Arduino APIs, you will find that this is the method used for the string constructor, which we have discussed in a previous lecture. This method is not part of ANSI standard C, but it is supported by many compilers. The function takes three arguments. The first is the numeric value to be converted to a string. The second is the string buffer to hold the results. And the third is the number base to be used. Here, unlike a string constructor in Arduino API, the base system is indicated by an integer. For example, 2 for binary, 8 for octal, 10 for decimal, or 16 for hexadecimal. Here the returned character pointer is redundant and points to the string passed as a buffer in the arguments. A variation a2i exists for the reverse operation and converts from string back to integer. Now let's talk a little about memory management using C language. So far we have been talking about a string buffer, but we haven't specified how this buffer is created. C programming language provides APIs to allocate and free memory. The method malloc does exactly that and takes as a parameter of type size_t the number of bytes to allocate. For example, an integer would require 4 bytes, a variable of type long would require 8 bytes, and a character would require only 1 byte. This method returns a pointer to the newly allocated memory location. Void pointer is a generic way to say that the pointer would work with any built-in data type, such as an integer or a character. Now the question is, how would we know the size of the variable we want to create? C provides us with a built-in method sizeOf that returns the size in bytes of a given operator. The operator could be another variable or a data type. For example, sizeOf_integer would return 4 bytes. Then we can multiply this value by another number if we would like to create an array of integers, just as an example. This concept should become clear from the code along part, so let's go to hands-on exercise. So we start with an empty sketch file, and let's define another method for the conversion from decimal to binary. The method should return a string, and let's call it decimal to binary. You'll wonder why I have not just used this for decimal or bin for binary. That's because this to bin is a reserved keyword in Arduino API, but we are building the method again so that we can demonstrate some concepts and learn them at a very low level. Once again, we use a long type, unsigned long, val, assuming both positive and negative values and assuming large values. And then let's define the array size, constant unsigned integer type, rename it 8 size and give it the value 8. And then let's make things more interesting and learn the concepts we have just demonstrated in the slides. And let's use a character pointer, name it buff, and let's do the casting from void pointer to character pointer. Now you understand that I will use malloc or memory allocation, and then I'll ask it to assign the size we've just created, 8 bytes. So that will return a void pointer, then the casting will convert it to character pointer, and then buffer will be the starting address. Now let's use the method itoa. Now let's pass the val first, and then the buffer for the output, and finally the number base to be binary or base 2 numbering system, semicolon, and return buff. Let's test the function inside setup. We do that serial.begin 9600, and then string str equals decimal to binary, and let's use the same value 134,134, and let's print the result. Let's save, Control S. Now let's upload the file. Now it's done uploading. Let's open the serial monitor. Let's clear and let's restart from the reset button. So if you hit the reset button, you should get the result, which should be the same as the one we had in a previous video lecture for converting the same number from decimal to binary. Now that you have mastered a few conversions between different numbering systems, and you have learned how to do the same thing using many different methods, in the next video lectures we will focus more on some techniques for building the actual library using the Arduino standards. See you in the next lecture.